Today we study another technique to broaden the library of functions that we're able to integrate, and that's a technique called trig substitution. It's a unique type of substitution that involves trigonometric functions. Now, the basis of this technique lies in the Pythagorean theorem and in its corollaries. So, the Pythagorean theorem, or Pythagorean identity, says that cosine squared plus sine squared equals 1. Now, as a consequence of this, if you go through and you divide everything by cosine, you'll find that 1 plus tan squared is equal to secant squared, if you divide everything by cosine squared. Or, put another way, tan squared is equal to secant squared minus 1. Now, with that in the margins, let's consider the following review exercise. Suppose that we have a constant a, and we let x be equal to a times sine of theta. If you have an expression square root a squared minus x squared times dx, how could this be rewritten so that it's completely in terms of theta, not in terms of x? So, to begin with, I will take dx d theta is equal to a cosine theta, or put another way, dx is equal to a cosine theta d theta. Let's put a little bridge in here. Now, having figured out what is dx in terms of d theta and in terms of theta, and now knowing what x is, I can plug in, instead of x squared, I will plug in a sine theta squared. And instead of dx, I will put in a cos theta d theta. Now, this radicand, this quantity under the square root, becomes a squared sine squared theta, which is speaking to me of Pythagorean theorem, because Pythagorean theorem says that cosine squared plus sine squared equals 1, or in other words, cosine squared equals 1 minus sine squared. And what we have under our root is exactly that, except that we have multiplied both of our terms by a copy of a squared. So if we go ahead and use the Pythagorean identity, we can replace the quantity under the root with a squared times cosine squared. And since everything under the square root is a product of squares, this can be simplified to a cosine theta times a cosine theta d theta, or a squared cosine squared theta d theta. Simplifies beautifully. Now, a similar technique can be applied to a different radical expression, which has not a subtraction underneath, but which has a plus sign underneath. If I plug in the substitution x equals a tan theta, then dx can be thought of as a secant squared theta times d theta. And if I substitute, I'll get a squared plus a squared tan squared times a secant squared d theta. Once again, I can go back and I can use one of the forms of the Pythagorean identity to simplify this square root so that it no longer contains an addition in its radicand. Square root a squared secant squared times a secant squared d theta. And after simplifying that, we get a cubed secant cubed d theta, a squared secant cubed theta times d theta. Another much simpler expression than what we had before, because there is no square root and plus sign combination. Likewise, if we have a subtraction but a subtraction in a different order. If we have x squared minus a squared, and we tried the substitution x equals a secant theta, then dx would be a secant theta times tangent theta, d theta, x squared replaced with a secant theta becomes a squared secant squared minus a squared, and here's dx outside. And as a result of this other formulation of the Pythagorean identity, this other formulation, secant squared minus 1 can be replaced with tangent squared. So, accounting for the a squared that we have, this becomes a squared tan squared theta. Once again, we've managed to get rid of that addition under the root and transformed it into a multiplication under the root. So this can be simplified as a squared times secant times tan squared theta, completely eliminating the root. Now, all of that to say that if you're integrating something that contains one of these three forms of radical expression, try one of the substitutions suggested on this page. For the square root of a squared minus x squared, substitute x equals a sine theta. For square root of a squared plus x squared, substitute x equals a tangent theta. For square root of x squared minus a squared, substitute x equals a secant theta, and use the Pythagorean identity to simplify that quantity, and maybe you will end up with something that is easier to integrate than what you originally had.